Hi guys, we are discussing the GATE 2015 question paper. One of the question was the major product K and L formed in the following reactions are. So this compound is treated with NaH with an allyl chloride. The product K is formed which on heating and then PdCl2, CuCl2, O2, H2O. The product M is formed. So we have to determine K and M. Now if it is treated with a strong base like sodium hydride, it will abstract the proton from this OH and the phenoxide ion will be formed. So O minus CH3. Now it will undergo SN2 reaction with this allyl chloride, and it also may undergo SN2 prime, but as this is more hindered side, so it will attack in this position, and an allyl ether will be formed. Allyl ether. So this is the K. This is the K. Now this allyl ether on heating will undergo Claisen rearrangement. Which is actually a 3,3 sigmatropic rearrangement. So what will happen? So 1 2 3 1 2 3. So the product will be, this will be double bond O, and here the hydrogen. Now it will undergo aromatization via ketoenol tautomerization. So the product will be here will be a CH3. Now if it is treated with PdCl2, CuCl2 in presence of oxygen and H2O, what will be the product? This is actually the Walker oxidation condition, Walker process. In Walker process, what will happen? An alkene will be converted to the carbonyl compound. That is, if ethylene is treated with PdCl2, CuCl2 in presence of O2, H2O, then it will be converted into CH3CHO. Here first half O2 will add, that is one atomic oxygen will add into this one of this hydrogen, so it will be OH, and it will undergo the ketoenol tautomerization to form the corresponding carbonyl compound. And if we take propene, then under similar condition we will get acetone, CH3COCH3. Here also the oxygen will add into the more substituted hydrogen, the hydrogen which is attached to the carbon which is more substituted carbon, so it will be OH. So the OH will be attached to this carbon, and after that it will undergo ketoenol tautomerization to form the acetone. So in this reaction, if it is treated with the Walker process condition, then it will be a COCH3. So the product will be OH, it will be COCH3, and here will be a CH3. So this will be the product. So the next question, the Beckmann rearrangement of a bromoacetophenone oxime, which is molecular formula this, gives a major product having the following 1H NMR data. So 9.89 singlet 1H, 7.88 singlet 1H, 7.45 doublet 1H, 7.17 multiplet 1H, 7.12 doublet 1H, 2.06 singlet 3H. We have to determine the structure of the product. So first, the bromoacetophenone means a phenyl group is there, this is the acetophenone, and if bromoacetophenone means one of the bromine is attached to this phenyl group. Now we have to determine if it undergo reactions with NH2OH in presence of H plus, then two product will formed. In one, the CH3 group will be anti to this OH group, and in another product the aryl group will be anti to the OH group, that is this, the aryl group, this will be anti to this OH group. Now if these two undergo Beckmann rearrangement, if it undergo Beckmann rearrangement, let's say PCl5, then the product formed will be, here the CH3 group will migrate and the product will be the aryl C double bond O NHCH3, the amide will be formed, and from this we will get the product. Here the product will be CH3 C double bond O NH, here the aryl group will migrate and the corresponding amide will be formed. Now the product of this the 1H NMR data for this amide are given here. We have to determine what will be the major product, that means either this or this. So here if we see the 1H NMR data, then we can see that 9.89 singlet 1H, so it must be the hydrogen which is attached to the electronegative atom, so that is for this hydrogen which is connected to nitrogen. Now here 4 hydrogen in the range of aromatic region, that is 7.88, 7.45, 7.17, 7.12. So 4 signal in aromatic region. Now if we take the 3 isomer, let's say we have to determine the Br is either para or meta or ortho. So how we will determine from NMR data? If we see that in the para form, these two hydrogen, these are H prime and these are H, we can pass a plane through this molecule. So this molecule can be divided into two equal halves. So this H prime will resonance at the same frequency and these two hydrogen will resonance at the same frequency. So from this compound we will get 2 signals only, 2 signals from in the aromatic region, 2 signals. Now for meta we will get no plane of symmetry is there, so we will get 4 signals. signals, and from ortho also we will get 4 signals. Now, so it will be either ortho or meta. Now if we see the signals, then here one singlet is there, one doublet, and one multiplet. Now for meta, this hydrogen will come as a singlet because no other hydrogen are there with respect to ortho with this hydrogen. So this hydrogen will appear as a singlet, and this hydrogen will appear as a doublet because of this hydrogen, and this two hydrogen will appear as a doublet. So these two doublet will for these two hydrogen, and this hydrogen will appear as a multiplet because of the splitting of these two hydrogen. So this is singlet and these two are doublets, and this is multiplet, and here no singlet will appear. These two hydrogen will appear as a doublet, and these two hydrogen will be multiplet. So our 1H NMR data corresponds to this, that is the Br must be at meta position. Now from the other data 2.06 singlet 3H, so this must be for this CH3 group. Now if the CH3 is directly connected to a strong electronegative nitrogen, then it must appear in 3 to 4 ppm, but it appears in 2.06, so it must be attached to carbonyl group, that is CH3 is not connected to strong electronegative atom like nitrogen. So the structure of the major product will be CH3 C double bond O, here NH, and aryl group where the Br will be in meta position. So this will be the structure of the major product. So guys, if you have any doubts regarding this video, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you. Have a good day.